Before we start talking about parallel and series circuits tomorrow, we need to make sure that we can analyze and solve for simple circuit problems. So this is a simple circuit, this number one here. They tell us in the problem, or if we look at the problem rather, we know that we have a battery, we know that we have an ammeter, we know we have a resistor, and we know that we have a voltmeter. All of these symbols come right from your reference table. Make sure that you're looking at your reference table to solve these problems. All right. So for number one, what should the ammeter reading be? All right, well, we know that they tell us that we have a potential difference of 27 volts. They also tell us that we have a resistor that measures 18 ohms. We are looking for I for our current, the current that is going to be measured as you go throughout your circuit all the way back around. All right, so if we are solving for I, we know that we can use our Ohm's law formula. So I know that I can use V equals IR. If you prefer your reference table, R equals V over I, it's the same exact thing. I like to do this linearly, as I'm sure you do, get rid of the fractions. So I'll stick with the V equals IR. So we end up with 27 is equal to I multiplied by 18. Solving for this, you should end up with I equals 1.5 amps. For B, what should the voltmeter reading be? Well, voltmeter measures the voltage in your circuit. And the voltmeter in this case is placed around the 18 ohm resistor. The total amount of potential difference flowing through that 18 ohm resistor is the 27 volt battery, or the 27 volts for that matter, provided by the battery. See how much power is delivered to the resistor? Okay, well, I know that I'm looking for P. In order to solve for P, I can now fill in 1.5 amps into my givens over here. In order to solve for P, you can use any formula that you would like as long as you're given the information. So for me, I'm going to choose to use P equals IV. You could use V squared over R. You could use I squared times R. As long as you are using what you have, that's totally fine. We should all get the same answer. So I is equal to 1.5, not 0.15, 1.5 amps multiplied by your 27 volt battery is going to give you a total power of 40.5 watts. For letter D, how much energy is delivered to the resistor after 1/2 hour of usage? Well, we know that we need to make sure that we are always talking about our time in seconds. Here they tell you that you have 1/2 hour. 1/2 hour is equal to 30 minutes. 30 minutes, we can then go ahead and we can convert to 1 minute is 60 seconds, making sure that your units are always going to be in seconds for time. And if you do this, you will end up with, 30 times 60, 1,800 seconds. Okay, that's my time. We are looking for energy, so we're looking for W. We're looking for the amount of work in our circuit. I'm going to go ahead and I'm going to use, what formula should we use? Let's use work is equal to VIT. Okay, so V is our 27, I is 1.5, and our T we solve for to be 1800 seconds. If we solve for this, our total work should be equal to 27 times 1.5 times 1800 gives us 72,900, and our units should be joules. All right. Whoops. Oh, there we go. Okay. Moving on to number 2. Here we have this circuit. Again, we're given a battery, we're given an ammeter, we're given a resistor, we're given a voltmeter. It's important to make sure that before you do anything in the problem, you know exactly what's given to you. I'm going to go through. We're going to write out our givens. V is 90 volts. R is 9 ohms. The first question asks us, what is the ammeter reading? Ammeters, we know, is going to measure our current. Again, I'm going to go ahead and use V equals IR. V is 90 volts, is equal to I times 9. I should be equal to 10 amps. Once I solve for that here, I could then go ahead and plug it into my givens on the side. What should the voltmeter reading be for letter B? Well, again, the voltmeter is placed on the outside of my circuit. That's also important, making sure it's on the outside of your resistor. It's going to measure the total voltage or the total potential difference flowing through. In this case, 90 volts. How much power is delivered to your resistor? Let's use a different formula for this one this time, and let's try P equals V squared divided by R. Again, you can use any formula you choose. We end up with V squared, so 90 squared divided by R is 9. If done correctly, we should end up with 900 watts. For letter D, how much energy is delivered to the resistor per hour? All right, well, so for this, again, we're looking for work. This time I'm going to use the work equals P times T formula. The first thing that we want to do, convert our 1 hour to seconds. So 1 hour is equal to 60 minutes over 1, multiplied by 60 seconds in 1 minute. Our total time should be 3,600 seconds. I almost said 120. I was adding them together. 3,600 seconds. Okay. So now as I go through and I solve for this, my power we already solved for to be 900 watts. My time, 3,600 seconds. Your total work should be equal to 3,240,000 joules. You could have also written as 3.24 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th joules. On the second page, you're going to use the following information for questions 3 through 5. So they tell you that you have a circuit made with a 5 ohm resistor, 24 volt source of potential difference. They also tell you that you have a single ammeter placed in your circuit to read the total current. The first thing that we would like to do is draw a diagram of the circuit using the symbols that are provided on your reference table, as well as labeling what we have. Okay. You can draw this a multitude of ways. Either way, you need to make sure that you have all of the different symbols and components in your circuit. You also don't want to add anything that is not given. So what I mean by that is you do not want to add a voltmeter into your circuit because they tell you that you don't have one. So don't add one in. Just put exactly what they ask. What happens when you start to add extra information or extra labels into your pictures, the moment that you do something wrong, your whole question is wrong. So keep it simple and just put exactly what they ask you for. All right. So they tell us that we do have a battery. So I'm going to start my battery right down here. My battery has to be connected with wires. They also tell us that we have a 5 ohm resistor. So I have a resistor right on the side here. Then they also tell us that we have an ammeter, and this ammeter has to be placed in series or has to be placed inside of your circuit. So it should look like this. And you have to make sure that you finish your circuit and connect it so that it looks like this. We do have a 5 ohm resistor. They tell us to label what we have. Labeling means the numbers, not labeling that you have a resistor. We know it's a resistor just by looking at the picture, as well as a 24 volt battery. You could have done this a couple of different ways. So I'm going to just show you a couple of different ways you could have done this here. You could have started it out that the battery was over here and your resistor was this way, right on the top here. You could have then went ahead, gone around and put your ammeter over in this corner. You could have put your ammeter right over here, as long as you have all 3 components. So as long as this arrangement is set up so that you have all of your components separated by an individual wire, all three of your components inside your circuit, it would have been correct. For number 4, determine the total circuit current. We're looking for current, so we need to know what we have first. So they tell us that we have V, which is 24 volts. We also know that we have R, which is 5 ohms. We're looking for I. We're going to use Ohm's law to solve for this, so V equals IR. V is 24 volts equals I multiplied by 5 ohms. I chose to put in your units here. Some of you like to do that, some of you don't. As long as they're on the side, that's all that matters. They do ask you for units, substitution with units, your equation, make sure you have everything listed. I, if solved for correctly, should be 4.8 amperes. Lastly, for number 5, let's draw a line here so we see what's going on. We are looking for the total circuit power. Again, we want to make sure we're showing all of our work. We're looking for P equals something. We know that we have volts, which is equal to 24. We know that my resistance is equal to 5 ohms. We just solved for it to be 4.8 amps. So again, you can use any formula that you would like as long as all of your given information you can use. So let's see, I'm going to use P equals IV. P is equal to 4.8 multiplied by 24. P is equal to 115.2 watts.